Welcome to Study Loop.
So firstly, we apply Ampere's law to a circular path of radius r. And Ampere's law says that the line integral of B dot dl, where B is the magnetic field, is equal to mu naught times the enclosed charge. And from here we can see that the line integral of B dotted with the path dl is simply B times the circumference of the circle with the radius r, that's 2 pi r. And from Ampere's law, this is equal to mu naught times current I. The current I is the current that's enclosed in the circular path. And therefore, if you rearrange this to solve for B, you get that the magnetic field within the toroid is equal to mu naught times I over 2 pi r. So hence we have an expression for the magnetic field. Next, we know the energy density which we are asked to use. The energy density is B squared over 2 mu naught, and hence the infinitesimal energy element du is equal to the energy density times an infinitesimal volume element dV. This is U times 2 pi r times L dr. So we just expand dV, the volume element, and hence du is written as, and we put our expression for the energy density from above to be 1 over 2 mu naught times our expression for the magnetic field, mu naught I over 2 pi r all squared, times our volume element, which is 2 pi r times the length of the solenoid L times r. And if we simplify this, we get an expression mu naught times I squared times L divided by 4 pi r dr. So an expression for the infinitesimal change in the total energy. So next, we can find the total energy by integrating the infinitesimal energy changes du. And we can solve this integral by plugging in our values from above. This is mu naught I squared times L over 4 pi, which are all constant with respect to r, multiplied by the integral from A to B of dr by r. And this is simply mu naught times I squared times L over 4 pi. If we evaluate the integral, we get that to be the natural log of B minus the natural log of A, since the integral of 1 over r dr is equal to the log of r. And we can go one further and write this as mu naught times I squared times L over 4 pi times the natural log of B divided by A, since we know the log of B minus the log of A is equal to the log of B over A. So hence we have an expression for total energy. Lastly, we'd like to calculate our inductance. Okay, and we know that total energy stored in the inductor U is equal to a half L I squared. And therefore, a half Li squared is equal to our expression for the energy above of mu naught I squared L over 4 pi times the natural log of B over A. And we can rearrange this and solve for the inductance L. And the inductance L for the solenoid of length little l can be shown to be mu naught times L over 2 pi times the natural log of B over A. And so the value for the inductance that we obtain from these energy considerations agrees with the value for the inductance as calculated in problem 30.48.